hell am I supposed to say? Because I mean, all that this data is giving me, like, I mean, all that we even really need for this is really the like the mean.
Well, I think
And
we're supposed to talk about it in real world situations, right? So I think it's really I think it'd be talking about, you know, why we're doing what we're doing,
oh,
what
okay,
our initial hypothesis was, and why we thought, you know, like you know, we thought that because, you know,
they're
taller
bigger.
athletes would have a bigger
Yeah.
strike zone and have more to protect with, you know, pitches coming in at, you know, upwards of 100 miles an hour, da 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 da. That this, you know, so I would, that's where I'd kind of go with it, is talking more real world, and then
Okay.
kind of like how, and then, you know, let's talk about, you know, we were a little surprised that when we did find the data that it was actually the
Other way
slightly
around.
opposite, but you know,
Yeah.
wasn't very statistically significant, blah blah blah. But yeah, that's, I think, what we're more than, because I think on the thing it says specifically not to talk about your p values and your
Exactly.
da da
Yeah.
da da da. So I think it's more about the talking that way. Hang on one quick second, I'll be right back.
So,
That's good.
so on the inference, that's where I'm gonna be doing the p-value and the what you call it, making inference.
Yes.
We're rejecting the null hypothesis, or what's our hypothesis? Remind me again. Is that the one that I posted on our chat board? Our hypothesis.
When.
Hold on. Let me copy it and repaste it again. Copied it from our thing, unless it's the wrong one. Let's see.
Okay, I'm back.
Hold on. Oh no, I pasted the wrong one. Sorry.
It's all right.
It's still on the copy and paste. Is that one?
Let's see. Um.
So
Is it?
I don't think we were using the hypothesis of with 255. I think we thought,
Or it's just that the sample. That could be the sample from the design the study.
but I'm saying, at least right there, the HO and the HA are not correct, right? I think
I think.
our HO is that it's less than, and the HA is that it's not.
Well, I thought that the HA was the less than because that's what we were trying to prove. Is our theory was that it was less than, but the alternative would, or
Oh,
not the
right.
alternative,
Okay. No,
the
you're
null.
right. You're right. I'm getting that backwards. But where are you getting that 255 number from?
I don't know. I think it's just the sample. But anyways, what's our number for
So I
HO
think
is equals
then
to?
the null would be HO is that 6 feet and up is equal to, I guess, 6 feet and under. And
Well, no,
then the
I can let me pull real quick. I can
The
pull
batting average.
the average, the overall batting average. I can pull that really fast. Hold on.
So when I make the my part, then I can do say we reject the null because
Well,
there's not enough
yeah, there's not enough
insufficient
evidence.
evidence.
Is our p-value lower than that?
Yeah, I gotta go check that one out. I can't remember which is the p-value on this. I know the test is statistics, but I need to figure out which one is the p-value. Or do I have to compute it?
I don't know. It should have it in there, I would have thought.
Is it the F? Hold on. Yeah, I'll just go back and see which one is the p-value and let you guys know. So HO is equals to something, and then HA is less than that.
Yeah. Is the p-value the significance thing the 0.065?
Let's see. 0.65. Where is that? Is that are you looking at the oh, yeah, significant two-tailed?
Oh, let's think.
This is that the z-score? No. Hold on, let me go check the our lesson. What lesson is that? 8, 9, no. Exam lessons. 12. Pair data. Inference for 2 means independent sample. Okay. Lesson 13. Oh, so we need to calculate the p-value. The t is 0.49. Okay.
So the overall average is, so it should be 0.283.
Is the overall.
0.283. Okay.
Which I guess makes sense because it wasn't that what both of them were anyways.
Fairly close.
Yeah. I mean, that's rounded to 3 decimals. I mean, it's obviously not, the numbers.
So our hypothesis thing is the null is equals to 0.283 and then or less than that.
Yeah, that's the full number, but obviously we're not putting that full number in. But
yeah, and the next number after the 2 is 9, so that's
pretty
dang
yeah,
close.
and 6 after that. So
yeah.
Hold on. Okay. So the top one is yeah. Okay.
So the null would be, would we say it's equal to 0.283 and the alternative would be less than?
Less than. Yep.
So
okay.
The 6 feet above is equal to
and above, though. Make sure we put that. It's equal to 6 foot and above, or 72 inches, or however you want to state it.
6 feet or equal to and above. Okay. Is equal to 0.273, and our null hypothesis is less than.
Correct.
But it's 0.283, right?
0.283, yeah.
0.283, yes. So, okay. So that's my thing, and I got way too many papers on my desk. But anyhow.
We have not done our quiz yet, right?
Not yet.
Okay.
That is correct.
What happened to my screen? I got way too many icons open up. I will have many no sleepless night until the finals.
Yeah, I'm ready for a break from school.
I got a lot of project. I have 3 projects to finish. This one and 2 more.
In one of my classes, I have a project due tomorrow, one due next week, and then one due the week after.
At least the accounting one, we just have the project for the finals, and we're not doing anything else from
Oh, nice.
today until the finals, until we submit that. But we have to do presentation and all that. So,
Oh man.
but at least less thing to study to review.
Right.
Yeah, I've been lucky. None of my classes looks like this is the only one that really has like a project due.
And I got 3. And the other one, I still need to type up all the information on my spreadsheet. So that will be fun.
So, do we have something else, or are we ready for the quiz?
I think we're ready for the quiz.
Let's do it.
Okay. Sorry. Hey, I'm on my class meeting. Okay, love you, bye.
Come on. I am really struggling with this computer to like
I was earlier.
Well, no, it's just like when I take quizzes on here, it's like the quiz just seems to hang a lot. Now trying even an evil Internet Explorer right now, see if it'll help.
Have you guys noticed that half the time they give us this normal probability applet and then we don't touch it?
Yep.
Yes. Yep. Always the case.
All right. Given the linear regression equation, y equals 2 and plus 1.5x, what is the y-intercept?
That would be the 2, right?
The y is the 2.
Well, but it's y equals 2 plus 1.5x.
Let's see.
Oh, so do we have to isolate that?
Let me see.
I don't remember them going over that in this thing.
Y is equals to, what are we looking for again?
Y-intercept.
Y-intercept. So it says here, y independent variable is x. Independent variable is x, and a dependent variable is y. So predict the value of y for any given variable x. So y is equals to mx plus b. So what is m? Is the slope, and b is the y-intercept. So what is the given problem?
I'm pretty sure it's the 2.0.
Okay. Let's try that.
Yeah, I think you're right.
And then the slope would be the 1.5 in the next one. What is the predicted value of y?
Given the linear regression equation, y is equals to.
So given the linear regression, what is the predicted value of y when x equals 16?
Or would that just be 1?
Where's my paper that I computed? Oh, dang.
Let's see. 0.25 times.
Yeah, y equals 1.
16 minus 3. Yeah, okay.
The next 7 questions, use the data file here.
We're using
So confidence, explanatory. Confidence.
I'm on my wrong computer. I don't have my Excel stuff on this one.
Uh-oh.
what?
Confidence. Explanatory.
So make a scatter plot of the
Okay.
Okay. Which one is that one? Lost it.
So what was the question? Make a scatter plot of the 3 data shapes introduced in the reading. Which shape best describes these data?
Okay.
Is that kind of like a hot dog? Or is it like a hamburger? I don't think it's a banana.
Scatter plot. Where's my scatter plot thing? There you go. Go insert scatter plot. It's all over the place.
Yeah, I would kind of lean towards maybe a hamburger.
Uh-huh.
I don't think it's a banana.
No.
Okay.
It doesn't look like a banana at all.
So it says, based on the shape of the scatter plot, what can you say about the appropriateness of the similar linear regression of these models of the data? Is appropriate for these data, will not be reliable, or is not appropriate for the data? Simple linear regression.
Didn't it say that hamburger means it was not appropriate?
Let me check. Hold on.
I believe you're right.
Let's go back.
Yeah, hamburger linear regression is not appropriate.
Okay, so we got
How many observations are in the data?
Do we have to, what? Do we just count how many responses there were, or how many variables there were?
how many observations are in the data?
And what does that mean? Is that
the total, the N?
there's 140 minus 1, so there's 139 samples, but I don't know if that's what it's asking for.
I don't know if that is either. That would be my first instinct.
So, let's see.
Let's try it.
You want to just go with that, 139?
See, and now my stupid thing is stuck. It's not saving. So after question 5, it's not saving my answers. And I have to open it up again. Oh, it's so frustrating.
So how many observations are in the data? So the observation is the score.
The score? Where was that?
Or confidence. Did I open the right one?
I don't know.
Confidence rating mean. Yeah, we're talking about the same thing. It's 139. The count is 139. Average is 74.2. So, what computer are you using? It's not the one that you usually use?
No, I usually use my Mac downstairs. This is actually a very powerful PC, but it's not being happy. Okay. I'm with you again. What is the y-intercept?
Where is that in our thingy majigger?
Ah, the thingy-majigger.
Yes, the Excel, whatever we call it, the linear regression thing.
Yeah, I don't know.
I don't know. I open up all of my thing. It's not. Let's see. Maybe because I'm not. No, that's not it. Let me check which one is it. Descriptive. Yep.
Oh, here we go. The y-intercept is in the unstandardized coefficients thing. And it looks like it's 18.690.
How did you?
So in the linear regression thing, the first table that you see after confidence level, the first table is model summary. And then the next one down is unstandardized coefficients. And then in that one there's a y-intercept and a slope.
Oh, linear regression. There you go. So we have to put the information there then.
Well, I think it fills it out for you.
Yeah. Then you said it also tells you the slope, right?
Yeah, the slope was 12.695.
Okay.
Oops. The what is the y-intercept again? Sorry.
18.690.
And the slope is
12.695.
thank you.
And it froze again.
Let's see.
And let's put the data in there so I know. Oh, so the X is the female and the Y is the male.
No, I don't think. Maybe.
Hold on.
Let's see. To enter, choose Excel to predict the value of Y. Enter the confidence prediction. And enter the value. Okay, so the question was X equals 4. Value of Y. Where does that come out at?
Prediction is
This is labeled predicted. 9. Okay, so are we ready for 11?
Yeah, I think. I don't know. My thing keeps freezing.
So for 11, we put 4 into the little blue box below the X, and the predicted value is 69.469.
69. 4.69.
Okay, 12. Confidence data result to determine the student's value in the question scale of 1 to 6. What is the value of Y for these values of X? What? The confidence data resulted from a student's value in the confidence scale of 1 to 6. I don't even know what's going on here.
So
Because there's a better correlation. We can use the largest X value to find the largest predicted Y value. So the maximum, if it's a scale of 1 to 6, the maximum would be all 6s, right?
Yes.
So how would that, so if we said those are all 6s, how would that affect the y value?
Because there is a positive correlation, we want to use the largest x value to find the largest predicted value of y.
What?
X. Let me read.
Is this continuing from what we were doing before?
I think it's part of that. Hold on, let's see.
So then do I just put 6 into
7 questions, so 1,
6?
2, 3, 4, 5, 6. Yep, that's the 7th question.
Okay, then I guess I just put 6 into the x, so then I guess it's 94.859.
Hold on, let's see. Six x. That's why hat.
Say that one more time, what that number was?
94.859.
I don't have a better answer for you.
Yeah.
My thing just froze again. Good.
How many explanatory independent variables are present in simple linear regression?
There's one.
That's kind of what I was thinking.
There's only because if you look on the graph that you use.
So that's independent, and then how many are dependent?
Okay, let's see.
I don't really even know what these questions mean.
Explanatory variables. There should be one. Let me check. Dang. No, not that one. Let's see, just a second.
Response variable.
Hang on 1 second.
So how many? Explanatory. So for the pivotal data, the independent variables is the head length, and we will use this to predict the dependent variable, the body length. Sometimes an independent variable is also called explanatory variable. The dependent variable is also called response variable.
So I just submitted my quiz. Both 13 and 14 are 1.
Okay.
Oops, dang it. No, don't do that. Crap. So everything was right except for the hamburger question. I accidentally just exited out of my thing. Everything was right except for the hamburger question and the question following it.
So it should have probably
So
been
what's number 15?
15 was the size of the hat because the variable being predicted.
So the first one.
So we may the hamburger size is not correct.
Correct. It's not. It is incorrect.
It's incorrect. So that could be
hot dog.
Let's see. Where's my graph?
1.65.
Well, just put in hot dog.
Okay.
I'm still trying to get my quiz to work here. So
Okay, I'll do hot dog and
do
see.
hot dog, and then but the one below it, then 7. If it's a hot dog, then it'd probably be the top one, A, right?
No, that's what we selected, isn't it?
No, we selected C. Right, Sam, you had hamburger, and then you said is not appropriate for the data, right?
Yeah, and
Okay.
hot dog.
Let me submit mine. Let's see.
So do hot dog and A.
Can you guys, Brad, can you remind me what the answer for 8 was?
Okay, that's all correct then.
Yeah. 139.
139. Okay. Let me see if I can find everything.
I can read them out to you.
Okay,
so I got 100. I got 100.
Okay, so number 9 is 18.690.
No, I don't need that. I need, let's see. Actually, I might have them all. Hold on. Y-intercept 2.0. 4 was 1.5. And then is 5. 5 was 1, right?
Mm-hmm.
Okay, I think I have it all now.
6 is hot dog and 7 is A.
Okay, yeah, I got them all back in there.
Okay.
Okay.
All right, 100%.
Yeah.
Sweet, I got 100% as well.
So we have to submit this document.
What?
Our project on
Saturday?
Saturday.
So do we each submit it?
No, I don't think so.
Okay, that's what I thought. So
I think this is my deal. So I think I'll compile it and submit it.
okay,
as long
so
as we have
I
all of our names on it.
do the write-up and then I send it in to you?
Yeah, or just I think email it to everybody, but I'll compile everything.
Yeah, send me a copy too, because I'm gonna be needing some of those when I do the inference.
Yep.
Okay. Sounds like a plan.
I'm just gonna hand draw a graph and with crayons and see if that works.
And a big smiley face.
Yeah, that'd be great. Well, cool guys. Well, I'm gonna head out. Thank you guys, and
thank you
yeah,
too.
if
And
you guys have any questions, yeah, just email, chat, or whatever as we go. But we should be able to wrap this thing up. So.
okay.
Sounds good. Have a good night.
You too.
You too. Bye.
Bye-bye.
Bye.